All right, so on 6.2, we're talking about the graphs of tangent, cotangent, secant, and cosecant. So I am more concerned about recognition of the graphs and identifying the different pieces rather than you actually graphing it. So we're not going to spend a whole lot of time graphing them ourselves so much as what's the period, or to find the amplitude, stuff like that. All right, so let's start with tangent. All right, so we're going to fill out this table. We're going to use decimals. We'll start with 0. So 0 has a tangent value of 0 because y over x, y is 0, x is 1. Pi over 6 has tangent values of root 3 over 3. As a decimal, that's about 0.6. Pi over 4, remember that's y over x. For pi over 4, that's root 2 over 2 divided by root 2 over 2. So that's 1. Pi over 3 is just the square root of 3. That's about 1.7, give or take. And then we get to pi over 2. Remember that's y over x. Y is 1, x is 0. So this is undefined. And since tangent is odd, then the opposites are here. So if I have the tangent of pi over 6 is 0.6, then the tangent of negative pi over 6 is negative 0.6. Tangent of negative pi over 4 would be negative 1. Tangent pi over 3 would be negative 1.7. And of course, pi over 2 would be undefined. All right, so when you have these undefines here, that creates an asymptote. So we have asymptotes, vertical asymptotes at negative pi over 2 and positive pi over 2. All right, so I'm going to grab the 0, 0 first. Okay, pi over 4 sits here in the middle. Pi over 3 is just on the other side. Pi over 6 is inside. And we're just estimating at this point. I don't know exactly where they're at on that line, but they're close. So we have 0, 0, pi over 6 and 0.6. Like roughly there. Pi over 4 and 1. Pi over 3 and 1.7. So like there. And then the other direction, negative 0.6, 1, negative 1.7. So what you should see here, and it's kind of subtle, is a little bit of a change in concavity right there. And concavity, when you do this in calculus, concavity is whether the graph like opens up or down. So right here, this graph opens down. But once I get to this point and I go up, that graph is slightly concave up. So right there is a point of inflection to change in concavity. So the graph ultimately looks like this. And the asymptotes, you get close to them, but you don't cross them. So what happens as we approach negative infinity? And this little plus sign means from the right side. So I'm coming at it from this side. All right, so as I'm coming at negative infinity from the right side, okay, what happens to the tangent graph? Well, it approaches an asymptote. I guess we can say it approaches negative infinity. And what happens as we approach positive pi over 2 from the left side? So that means I'm coming at it from over here. Well, that one's heading up towards positive infinity. So the asymptotes occur pi over 2 plus pi k. This pi k, that means that there's pi units between asymptotes. Not particularly worried about the x-intercepts. period of the parent function for tangent is pi. So pi between each asymptote. So the period is the distance between asymptotes. I'm out of space. So it's the distance between asymptotes. The range is negative infinity, positive infinity. And the graph is symmetric to the origin, which makes tangent an odd function. All right, so you can see that tangent has pretty much the same formula as sine and cosine. The stretching compressing, that just makes it skinnier or wider, is opposite value of A. The period is different because for sine and cosine, the period was 2 pi over B. For tangent, it's pi over B. Okay, phase shift, so moving it left to right after B has been factored out. The vertical shift is D. This also represents the location of the point of inflection, so changes in concavity. All right, so here's our formula for the asymptotes, which is super complicated. I'm not going to spend a whole lot of time on this. And this is where it says where K, and that weird symbol and that weird Z, this means K is an integer. All right, below is the graph of f of x equals 3 times pi over 6x. Identify each of the key parts, and I want you to label them on the graph. So the first thing I'm looking for is, if I can, is the amplitude. Okay, it's not what I'm asking for, but amplitude, I can see what that's. Period. Is pi divided by the b. Now, just like sine and cosine, I'd want to make sure that b was factored out. Since there's nothing else inside the parentheses, I don't really need to factor it out. And pi's cancel, so the period is 6. Okay, so that means the distance between the asymptotes. This distance, I'm gonna bring that down one. This distance, 6 units. Phase shift, none, because there wasn't a C. Vertical shift would be out here, none. Okay, it means that the point of inflection is at 0. Reflection, it's not negative, so also none. Okay, so our asymptotes are 6 units apart. Okay, below is the graph of -2 tangent x minus pi over 2 minus 1. Key parts, label them on the graph. Not particularly worried about the amplitude because it's really hard to tell amplitude on the vertical stretch of compression on a tangent graph. Easier on sine and cosine. I am worried about reflection. This graph is negative, so there is reflection. Which we can see in the shape of the graph. Okay, because typically tangent graphs are like this. All right, period is once I factor out that b. That b is a 1, so I don't really need to factor anything out. So the period equals pi divided by 1. So the period between asymptotes pi units. Phase shift, the C is positive pi over 2, which means we have shifted to the right pi over 2. And vertical shift, the D is -1. Down 1. Okay, so I drew those in there because of the pi and everything. So each one of these, this distance between the asymptotes is pi units. So from here to here is pi. From here to here is another pi. So that puts this one at 2 pi. Backwards, same thing. This one would be -pi over here. All right, point of inflection. It's been shifted down 1 unit. All right, so you can see it switches from concave up to concave down. Okay, so let's graph cotangent. And cotangent is the reciprocal of tangent, so it's x over y. That means I'm going to start with pi over 2, because x over y there would be 0 over 1, so this is 0. All right, I'm also going to do 0 next. 0, that's ordered pair is 0, 1. 1, 0, so it would be x over y, so that's fine. Then we do pi over 4 next, because pi over 4 is always going to be 1. And then 2 pi over 3, 3 pi over 4, 5 pi over 6, those are all quadrant 2, where it's negative, so 3 pi over 4 is -1. And pi, since it's x and y, it's -1, 0. It's going to be undefined. So as far as the pi over 3 and the pi over 6s, those are switched. So the cotangent of pi over 6 is √3. So that is 1.7. The cotangent of pi over 3 is its reciprocal, so it's going to be √3 over 3, which is 0.6. Cotangent is odd, so switch signs on the other side. So as I graph it, this time my undefines, my asymptotes occur at 0 and pi. Okay, and just like we did before, I'm going to graph these pi over 4s in the middle and close on either side. All right, so pi over 2 is 0. Pi over 4 is 1. Pi over 6. Pi over 3 is 0.6. Pi over 6 is 1.7. All right, pi over 4 is -1. Pi over 5 pi over 6 is -1.7. Pi over 3, -0.6. So again, you can see it follows the same sort of track as tangent. So what happens is we approach 0 from the right. Well, y approaches positive infinity. What happens to cotangent as we approach pi from the left? Well, y is approaching negative infinity. Okay, so the asymptotes occur every pi units. Period of the parent function is pi. Range is negative infinity over pi. Negative infinity over positive infinity. And it's symmetric to the origin. So cotangent is odd. Same order, same types of things we're looking at: A, B, C, and D. Stretch compression, that's A. Don't spend a whole lot of time on that with tangent and cotangent. Period, again, highlight that. Pi over B, after B has been factored out. Phase shift, C, after B has been factored out. Vertical shift is D, which is the location of the point of inflection. All right, so first thing I'm looking for, amplitude. It's not one of the things I'm looking for, but I want to see if that amplitude is negative. It's not, so no reflection. I'm going to check for the period. Period is pi divided by the B once it's been factored out. Well, there's my B, but there's nothing else inside the parentheses, so I don't need to factor it out. the period is 2 units. That means there's 2 units between each asymptote. Phase shift none. I didn't take anything out. There's nothing inside the parentheses there. Vertical shift down 1 because the D is negative. All right, so you can see the asymptotes are 2 units apart. I can see the point of inflection down 1 unit. And that's really all there is to it. All right, so graphing secant, and we're going to use decimal approximation just to make it easier to actually graph. So secant is the reciprocal of cosine. So if I consider the cosine of negative pi over 2, okay, that cosine's the x-coordinate, that's going to be 0. So its secant is going to be the reciprocal, which is undefined. Okay, negative pi over 4, that's going to be positive root 2 over 2, and I forgot what that value is. Calculator. Positive root 2 over 2. And 0.7. So it's reciprocal. And it's 1.4. All right, cosine of 0 is 1. The reciprocal of 1 is 1. Cosine pi over 4 is 0.7. Cosine pi over 2. How did I just lose my train of thought? 0, so it's going to be undefined. Cosine 3 pi over 4, that's negative. We've got the reciprocal. Pi is negative 1. 5 pi over 4. That's third quadrant, so it's still negative. 3 pi over 2. Cosine is 0, so reciprocal is undefined. So we have places, negative pi over 2, positive pi over 2, and 3 pi over 2, where the cosecant is undefined, which means I have asymptotes there. All right, and those asymptotes occur whenever the cosine of x equals 0. So what we're going to do, we're actually going to graph cosine first. All right, so cosine starts high, mid, low, mid, high. And same way. So wherever the x over cosine x equals 0, so that's when it's hitting the x-axis. So where we have asymptotes. So we have asymptotes here, here, and here. All right, so next thing I want to do, when I'm graphing secant, okay, it's really easy. Where there's mins and maxes of your cosine function, you have mins and maxes for your secant function. So I'm going to have a min, where there's a max, there's a min. So negative pi over 4 took me to 1.4, which is about here. And then positive. So it creates this U. And same thing happens over here, negative 1.4. And then it repeats on the other side. All right, so you can see the sine graph, or the graph here. Okay, this time though the period is 2 pi because one full repetition is oh gosh, well, since the period of cosine is 2 pi, that means the period of secant has to be 2 pi. Graph is symmetric to the y, which means the y is cutting it in half, so secant is even. Okay, stretch, compress. You're not really going to see a whole lot of that. It affects the shape of cosine, but not really the shape of secant. Period is 2 pi over b. Base shift, c, after the b has been factored out. And of course, the vertical shift, which is still the midline, is d. All right, and our last one. Cosecant, which is the reciprocal of sine. So sine 0 is 0. So its reciprocal is going to be undefined. For pi over 4, that would be root 2 over 2, which is 0.7. So this is going to be 1.4. For pi over 2, sine is 1, reciprocal is 1. For 3 pi over 4, that's still positive, second quadrant, so 0.7, which means the reciprocal is 1.4. For pi, sine pi is 0, so its reciprocal is undefined. 5 pi over 4 is in quadrant 2, so sine is negative. 3 pi over 4, the ly coordinate is -1. 7 pi over 4 is quadrant 4. That's negative there. Back to 2 pi where the sine is 0, which means the reciprocal for cosecant is undefined. So wherever sine is 0 is when we have an asymptote for cosecant. All right, so if I graph these, remember sine is mid-high, mid-low, mid. The asymptotes occur when sine x equals 0, so it's here, here, and here. So just like with cosecant, cosine and secant, the mins and maxes of sine tell you where your graph is going to have the u's. So I have a right side up u at a max and an upside down u at a min. Okay, so right side up u at a max, upside down u at a min. So I should have a minimum. So upside down u. I forgot to change this. This is cosecant. Same thing as secant. Stretch compress is A. Period's 2 pi over B. Base shift is C after the B is factored out. And the vertical shift is D. So how you would do your secant and your cosecant is the exact same way you do your sine and cosine because they're reciprocals. The only two that are different is your tangent and your cotangent.